Hello and welcome to the video for section 8.4. This will be the only video for this section. Section 8.4 is on plane curves and parametric equations. Now, if I was a student taking Math 127, this would probably be one of my favorite chapters. Reason being is the concepts are pretty straightforward as to what you have to do, but it's a problem you're going to see on exam problem you'll see on exam 3 and a problem you'll see on the final exam. It's usually a big point problem, and so if you just kind of stay calm, even though it's a big point problem, follow through the couple of steps. They really are fairly simple problems to do, and again, it's a way to get a lot of points on the final exam without having to memorize a ton of formulas or memorize a bunch of concepts like some of the other stuff we've had to look at. So within this section, we're only going to look at sketching parametric equations and eliminating the parameters. Those are the two things we're going to be doing. So let's look at an example of the kind of problem you'll have to deal with. So we want to sketch the curve defined by the parametric equations and eliminate the parameter. So you can see why this might be a big point problem. There's a couple things you have to do. When we're talking about a parametric equation, it just means that we're given a third variable that we have to figure into when we're plotting points, and then we have to eliminate the parameter. So then we have to go through a couple steps to get rid of that third variable. Again, on the surface it might sound like a lot to do, but it's really pretty straightforward. So the parametric equations that we're talking about here is x is equal to t squared minus 3t, and y is equal to t minus 1. So they're called parametric equations because we have another parameter. We have another variable that we're dealing with, in this case t. So if we were to graph an equation before, what will we do? We would we might have an equation like this, like y equals x plus 2. So how do we graph that? Well, we pick values for x. -1, 0, +1, 2, +3. We plug those in, we figure out what the value is for y. We're going to do the same thing here, but now because we have a t in both equations, that's the table that we're going to build. So let me do that over here. So I'm picking values for t. So I'll pick a couple negatives, so -2, -1, 0. Let's pick a couple positives, 1, 2, 3. See what this gives us. So now I want to find, using this parameter, t is -2, t is -1, t is 0, etc. I want to find out when it's -2, what's my value of x? When it's -2, what's my value of y? And then that'll give me a point that I can graph with an x coordinate and a y coordinate. So my x is t squared minus 3t. So when t is -2, x is -2 squared minus 3 times -2, which is 4 plus 6, which is 10. So when t is -2, x is 10. Y, when t is -2, so y is t minus 1, so y is -2 minus 1, which is -3. So that means that when t is -2, my xy coordinate is +10, -3. That's a point I can graph on my rectangular coordinate system. We're just going to do the rest of it for these other numbers. So when t is -1, we get -1 squared minus 3 times -1, which is +4. And when t is -1, y is -1 minus 1, which is -2. So this gives us a point for -2. When t is 0, x is 0. Y is -1. So that gives us a point 0, -1. When t is 1, we have 1 squared minus 3 times 1. So 1 minus 3 is -2. Yes, -2. And y is 1 minus 1, which is 0. So that gives us the point -2, 0. So if we keep working our way down, when t is 2, x is -2, and y is 1. So that gives us -2, +1. And when t is 3, x is 0, y is 2. So that gives us a point 0,2. So you see here we have when t is 0, x is 0. When t is 3, x is also 0. That's okay. So we can have points doubling up. We're just building this table based on our values of t. So now let me go ahead and graph this. So I'm just graphing now. I'm not worried about t anymore. I'm only graphing my x, y points. So what values do we have here? The first point is 10, -3. So that puts us at a point way out here. Our second point is 4, -2. So if we graph that, it's 4 units to the right, 2 units down. It gives us a point there. Our third point is 0, -1. So 0, -1, we're here on the y-axis. Then we have a point -2, 0. So that brings us over here. Then we have -2, +1. So that puts us here. And our last point is 0, +2, puts us here. So what do we have here? Well, if we start connecting these dots, this one here, we don't actually have, it becomes what, a parabola? We don't actually have what the vertex is on this parabola, but we're just sketching it. It doesn't have to be, to scale or anything like that. We just want to sketch what it looks like, and it's a parabola pointing to the right. So now I'm going to erase this table, so if you still need these numbers, go ahead and pause. So that's part one. I want to sketch the parametric equation. So that's the parabola here. The second part says eliminate the parameter. So what we're going to do, anytime we have to do this, we're going to solve one of the equations for the parameter. So in this case, t. Solve one of the equations for t, plug it into the other equation, and then simplify so that all we're left with is x's and y's. So let's look at this first one. We have y is equal to t minus 1. So if I want t all by itself, I need to add 1 to both sides. That means that t is equal to y plus 1. So now I'm going to plug that into my x equation. So I get x is equal to t squared, which is y plus 1 squared, minus 3 times t. So minus 3 times t, which is y plus 1. Now it's just a matter of simplifying. So y plus 1 squared, remember this is like y plus 1 times y plus 1. So if I FOIL it, I get y squared plus 2y plus 1. So that's from this first piece. And then here if I distribute the minus 3, I get minus 3y and minus 3. So now just combine my like terms. I get x is equal to y squared. We have plus 2y minus 3y, so that's minus y. And then 1 minus 3 is minus 2. So this equation here gives me the same as what this parametric equation gave me in that situation there. All right, so that's it for that problem. Let's look at another example. So in this last case, we had no restrictions on t. That's why when we built the table, we had -2, -1, 0, 1, 2, etc. Sometimes we might be given restrictions. So this problem is number 5 on page 569. And just like the last problem, we want to sketch and then eliminate the parameter. So I'm not going to go through writing all that, but the parametric equations we're given is x is equal to t squared, y is equal to t minus 2, but now t is restricted between +2 and +4. So when we build our table, these are the only values we can use, 2, 3, 4. You could use fractions and stuff, but hopefully the 3 points gives us enough of what this should look like. I want you guys to get some practice. Like I said, these are big point problems, fairly straightforward on the methodology to solve it. So go ahead and pause here, try to work this problem through based off of what we did in the last problem. Come on back, hit play, and then I'll work through the solution for you. All right, welcome back. So hopefully you're able to get through it. Just as in before, to solve this, we're going to build a table. But our values for t this time are only 2, 3, and 4. So x is equal to t squared. So that means we have 4, 9, and 16 on our table for our x values. Y is t minus 2. So 2 minus 2, 0. 3 minus 2, 1. 4 minus 2, 2. So if we graph this, our points are now 4, 0, so we have a point here. Our second point is 9, 1, so 4, 5, 6, 7, 8, 9, way out here, but only up 1 unit. And then 16, 2. So way out here. So actually, if I draw this a little more to scale. So it's kind of hard to see from this, but we get, actually, just that guy right there. It's kind of just the side of a parabola. But because we're restricted on our value for t, we're not putting arrows on the end this time. It just goes from this point, stops at that point. Again, because of this restriction on t. So be careful with that. If you're told to graph this kind of problem on a final, don't just let the line go running and put an arrow on it, because it's a little different kind of problem. Now we need to eliminate the parameter, so I'm going to use y again. So I get y is t minus 2, which means t is y plus 2. If I plug that in, I get x is equal to y plus 2 squared. And that's really, you don't have to work this out. There's no terms or like terms we have to combine or anything like that. So this is our equation. But if we're asked to specify the domain or the range for this problem, because it's not every value that satisfies that. Remember, our t was restricted from 2 to 4. So we have to limit where this equation is actually true. So what's our x values go from? They go from 4 out to 16. So what we can say is x is equal to y plus 2 squared, but x is between 4 and 16. Or, if we want to do it based on y, well, what are our values for y? 0, 1, or 2. So basically y goes from 0 to 2. So if we're given a parametric equation that has its restrictions on it, we need to make sure that we restrict our domain or range on our equation once we eliminate the parameters. So in this case, I would say x is y plus 2 squared, and y is between 0 and 2. That way I know the only values I'm going to get are 4, 9 and 16 if I'm using my integer values. All right, so that's that example. I'm going to erase this. I'll give you guys one more, some more practice. So just with this last problem, once I get it written, go ahead and pause. Try to work it through. See if you can solve it on your own. If you get stuck, go ahead and come on back. This is problem number 4 on page 569. Again, we want to sketch and eliminate. This time, x is equal to 6t minus 4. Y is equal to 3 times t. And t is greater than or equal to 0. So we have a little more freedom what values we can pick for t in our table, but it has to be 0 or greater. So again, go ahead and pause here. Come on back, see if you got it right. All right, welcome back. So my table I'm going to build this time is only my positive values and 0. So 0, 1, 2, 3. So x is 6 times t minus 4. So when t is 0, I have negative 4. When t is 1, I have positive 2. And positive 8 when t is 2. And positive 14 when t is 3. My y is equal to 3 times t. So that's going to be 0, 3, 6, and 9. For t is 0, 1, 2, or 3. So now if I graph this, so my first point is at negative 4, 0. So that's over here. My second point is at 2, positive 3. So that's here. I have 8 and 6. And then 14 and 9. So what do I get? I get a line that starts here at negative 4, 0. And it's a straight line that goes through all these points. Well, sort of straight. If I drew my dots in a straight line. But now do I stop there or do I keep going? Well, my table I stopped at 3, but that's just because I didn't want to put any more values. But remember, t can be anything past 0. So technically this straight line just keeps on going up and to the right. So now, when I have to eliminate the parameter, I can use again either equation. So let's use the y again. So I have y is equal to 3t. So that means t is equal to y divided by 3. I just divide both sides by 3. Plugging that into my x equation, I get x is equal to 6 times t, which is y over 3, minus 4. So the 3 cancels with 6 gives me 2, so I get x is equal to 2 times y minus 4. So that's my equation, but I do have this restriction because this thing doesn't go left and right to infinity. So I either have to restrict my x values or I have to restrict my y values. So my y values, because I've written x in terms of y, what's the lowest y ever gets? 0. How high does it go? As high as we want. So we can also say that y is greater than or equal to 0. So this would be the equation if we eliminate the parameter, but we want to give ourselves a restrictions on what values we can choose so that we were to get this same graph back. So that's it. 3 examples from section 8.4. All of them solve basically the same way. You build a table with t, figure out your x and y values. Once you have those values, plot them on a graph, and then to eliminate the parameter, solve one of the equations for the value of t, plug it into the other one, simplify, and if you have to have a restriction on your domain or range, go ahead and do that as well. So that's it for 8.4. Come on back and we'll delve into chapter 9.